Good afternoon, good afternoon to those from the other side of the world. Good evening to people from Matt's side of the planet. But to the rest of you, because I can see many people, well, a large chunk of those here, even though we are still a few number right now, are also from my same time zone. So good morning. Today we have a special guest, and as you've gotten in the previous announcement, it is something that many of you have been excited about. We getting the legendary Matt to come present to us about, an amazing topic also, which is DAX. And just to let you know who Matt is, I'm sharing my screen right now, and you'll be able to see the same event page that has been set up with its details and the information I passed earlier. Just to announce, the session is being recorded because, as you noticed, it is not the usual timing, and many people are not able to adjust to this new time. So that necessitates us having to rebroadcast at 6 p.m. So we have to have the full recording so that those who join that period will be able to benefit from today's session. So Matt is the owner of Accelerator BI, which if you had ever Googled about some problems in Excel, you are sure to come upon that site. He is one of my most preferred educator in terms of whenever I search for things or I'm trying to learn about the concept, and I see a lot of answers, I have a preference for picking his own because he has his way of writing and explaining concepts that I know that, I'm just going to get whatever he's explaining. Whereas some other times I click on other people's links and I'm like, oh, I'm not quite getting what this person is explaining. Let me go search again. But with Matt, I think he has the gift of doing it because I don't really know how he manages to break down really advanced concepts into very understandable chunk and does a lot of real life practical examples. So his profile is a career expert in Power BI. Power BI is recent. So he's a career expert in BI, has more than 30 years experience using data to deliver business value. He's also a Microsoft MVP, and he specializes in Power BI, Power Query, Power Pivot for Excel. He consults, so he combines his business and IT experience to deliver training, consulting, and general business data problem solving to clients around the world. He's the author of Supercharged Power BI. I think he also has one for Excel, Supercharged Excel. So it's a pleasure to have him here. And I'm going to hand over to him right now because I want to go and get the other people who should be here who have not yet been here. So Matt, please, the stage is yours. It's a pleasure to have you. Thank you.
Great. Well, thank you very much, Michael. Yeah. So look, I realize this is a bit of an unusual time for this user group, and but it's getting on in the evening here. It's just gone 7 p.m. here in Sydney. It's been a lovely summer day, last day of summer today. So, but yeah, I'm sure there'll be many others who will watch this as a recording. So we'll go ahead. And for those of you that are on the call, the weight is on your shoulders to ask questions. So the people that are watching, if they have the same questions, we can get them answered as well. And hello to Christian, special hello to Christian, who I know quite well. And yeah, so thanks for joining, Christian. Okay, so I won't go through an intro for myself. Michael just did a splendid job. So I've been doing this for years. I love doing this, and this is one of my favorite topics is DAX. And so in order to provide a bit of variety, I decided to talk about DAX as a query language. Some of you, well, everyone is at some stage of understanding of DAX, I guess, when they're in Power BI. And some people haven't come across DAX as a query language before. You probably know, but I guess it's important to know that Power BI is a database. This is a really important concept, particularly if you're coming from an Excel world, because Excel is not a database, it's a spreadsheet, and a spreadsheet and a database are very different things. And because Power BI is a database, then DAX can be used as a query language tool to query the database and fetch some data. And so I'm not going to get into a lot of depth. This is an introduction to DAX as a query language. It's to create awareness of what a query language is like and how you can use DAX as a query language. And I'm going to give you a few use cases to try and make it real. I'm not going to assume that you have a SQL background or you understand T-SQL or SQL script, although the SQL language, which is also a query language, is a very simple language to learn. So anyone can learn SQL, I believe. But I will talk about some of the parallels between SQL and DAX as a query language. So if you do have a little bit of an understanding of SQL, then hopefully I'll try and bridge that for you. But it's not a requirement for this session. All right, so let me start off by talking about some of the common, or the most common way that you would normally use DAX. This is what everyone uses DAX for, and that is to write formulas, to write DAX formulas. And they can be either measures or they can be calculated columns. They're the two most common uses for the DAX language. I'm sure you know DAX is short for data analysis expressions. And this language was built for people coming from an Excel background, not exclusively for that group of people, but that Excel group of users was clearly in the mind of the developers when they started this journey. They didn't want this to be a new complex language, say like MDX, which is another query language. They wanted it to be accessible for people, for business users who are used to the Excel language. And so as a result of that, DAX is a functional language. So Excel is also a functional language. So what I mean by that is that the language comes in functions. So sum is a function in Excel, sum is also a function in the DAX language. And so you have brackets and you pass parameters and you get the results back. And that was a very good decision that Microsoft made very early on. So when you normally use DAX, it will normally, under normal use, it will always return a scalar value. Now what I mean by a scalar value is it's a number or a text string or a date or true false expression. But at the end of the day, it's a single, well, the full term is called a scalar value. It's a number, text, true, false, date, that type of data, and it's a single data point. That's the important point about a functional language. So I have two examples here. So the first one is a sumX function. SumX is a little bit more advanced than sum. It takes a little bit of time to get used to it, but the way this formula works is that it works its way through the sales table, and for every sale it takes the quantity and multiplies it by the price per unit, and it returns the total sales. But importantly, the total sales is a single number. That's the key point about scalar values, that they're single numbers. So this is something that's a little bit more advanced down here. So we've got a calculate and we've got a filter function. We've got an all function. All is a table function. Filter is a table function. This is part of the filter function. Calculate is a very simple on the surface but complex beneath the surface function inside the DAX language. But despite all of this activity that's happening in this second formula, it still returns a single value. Total sales of bikes is still a single number. Now, depending on where it's deployed, you might see it in a column of a table, in which case you'll get many numbers, or you might also see it in a table on a visual or in a column chart or in a pie chart, and as a result, you'll see many numbers. But technically, these are just display techniques for single values which are being calculated. So it's a subtle difference. So if we move over to DAX as a query language now, that's a very different thing. So a DAX query still uses the same DAX language. So there's very little new things that you need to learn. Most query functions are common. There are some very unique functions like the evaluate function. So evaluate is a special function inside DAX as a query language. It's the only place it's used. And if you do know some SQL, it would be the same as select. So instead of saying select star, you would say evaluate. And there are some other functions in the DAX language that don't tend to be used a lot inside DAX as a functional language, so summarise and add columns. So these functions tend to get used a lot more inside DAX as a query language, although technically they can be used inside DAX as a regular functional language. And the way a DAX query works is the DAX query sends a request back to the database. It's the X velocity database that sits behind Power BI. And that request gets fulfilled by the database and the results get returned to you. And that can be done automatically by Power BI, or it can be done using one of the user tools that I'm going to be using today, which is DAX Studio. Now, importantly, when you write a DAX query, it always returns a table. So this is exactly the opposite to DAX as a functional language. When you write a DAX query, it must be a table. You cannot return a single value. Although I'll show you a bit of a trick on how you can get single values. And so when you send a query, the query is returned, and you can have any number of rows in that query: 0, 1, 2, billions. You know, there's no limit to how many rows can be returned. Okay, so let me cover a few use cases, and then we're going to dive into some examples just to show you how easy it is to get started with DAX as a query language. So the first thing you can do with a DAX query is you can send a query through to the database and extract some of the underlying data either in a detailed form. So maybe you wanted to extract a list of customers. That would be an example of a detailed form. Or you could also return a summary table. So you might want to return the top 10 customers and their annual sales, for example. You could do that with DAX as a query language. You can also use these techniques for archiving. So, we might get a chance to get to that. We'll see how we're going for time. I also like to call this concept poor man's paginated reports. So you may be aware you can use paginated reports inside Power BI desktop, but it's also possible to use to create this concept of a paginated report using DAX as a query language and the Excel as a front end, and I'll show you how to do that shortly. And then you could also create perhaps a summary table and load that summary table directly inside Power BI. And depending on your data model, there's a lot of dependence. You may get better performance from a summarized table than you would from a detailed table. It always depends inside Power BI, so I can't be sure about that. You can also use DAX queries to get your head around the formulas that you're writing. So one of the challenges of the DAX language is it's very difficult to understand the table functions that you're writing inside a measure. And so if you're going to debug your formula, you can use DAX as a query language to help you visualize each piece of the formula that you're writing and hopefully solve some problems. And then finally, well, this is not finally, but as far as the points I'm going to be covering today, you can also use DAX as a query language using DAX Studio to check the performance of your measures and hopefully improve the performance of your measures as well. So I'll show you how to do that. Okay, so look, I do have a couple more slides, but really that's the basis of the presentation. Just a couple of summary slides from now. And what I'm going to do is I'm going to jump into some demos and introduce DAX Studio if you haven't seen that before, and we'll write a few queries using the basics of DAX as a query language. Okay, so here on the left, I have a picture of the data model that I'm using. I think this is Contoso. It's actually a while since I've opened this. I think it's a Contoso database. So we have a sales table with 6.7 million rows in it, and we have customers, products, and employees. You can see that these tables, these are the dimension tables, or the lookup tables. They're quite small. The sales table is quite big at 6.7 million rows. Okay, so with that in mind, let me jump over. Here is Power BI, and this is that same sales database. If I jump over here, you'll see that I've got this. Just let me delete this. I think this was some when I was doing some testing earlier on, so just let me delete this. Sorry, I didn't realize I had that there still. All right, so here's the 4 tables that I showed on the slide before, and this sales table is 6.7 million rows. Okay, so I'm going to launch DAX Studio. So to do that, I come up to External Tools. You do need to have DAX Studio installed on your computer before you do this. I've got blog articles on pretty much everything I'm covering today. So if you go to my website, search for DAX Studio, you'll find an introduction to DAX Studio, and it'll tell you how to install it, and you can go from there. So I'm not going to go into that. So let me open up DAX Studio. This is much easier in the last probably 5 months or so since Microsoft allowed the integration of third-party tools with Power BI Desktop. And so when I launch DAX Studio, like I just did, from within Power BI Desktop, I automatically have this session of DAX Studio connected, and you can see the 4 tables. These are the same 4 tables that are in the underlying data model. Now, it's important to note that Power BI Desktop is running on my computer, and so this is SQL Server Analysis Services Tabular running on my computer, and DAX Studio has a live connection into that database. So anything I do now with inside DAX Studio is actually going to be a request from this application, which is basically a data query tool, or a DAX query tool, and it's going to send the request through to the database. So let me start off by writing my first queries. So I don't know if I can make this bigger. I'll make it bigger. Evaluate. So every DAX query must start with the keyword evaluate. So as I said before, this is the equivalent of select if you're in SQL. And the most simple query that I can write is just to specify the name of the table. So I'm saying evaluate the employees table. And when I run that query by clicking run here, you'll see down here that I get a table. Remember, every DAX query must return a table. So there's the table of employees. You can't see all the employees on the screen, but if you look over here, you'll see that there's 23 rows that have been returned inside this table. So that is the most simple DAX query that you can write. Please give me the employees table, and you write that just by saying evaluate employees. Now, if I try and do something different, so instead of evaluate employees, what if I was to say evaluate the sales quantity? So this is the sales table, and this is the quantity column. So I say evaluate the sales quantity column, and I run that query. I get an error. And the reason I get an error, you may already know, is because this is not a table. Sales quantity is not a table. Sales quantity is a column, and you can't return a standalone column unless it's part of a table. This is how the language works. And so if I want to return the column, I could do something like all sales quantity. So what I'm now doing is I'm wrapping the column that's inside my table inside a function called all, and the all function generates a table of all the unique values in that column. And so if I run that query, now you'll see that I get a table. In this case, it's a single column table containing 1,042 rows. And so this is a very simple query. Now, this column, or sorry, this table consisting of a single column is exactly the same as you would see if I jumped over here to the sales table and I clicked on the quantity column and clicked on this filter. This filter will give me a unique list of all of the unique values inside that quantity column. And so this is exactly the same thing. This drop-down list here is exactly the same list that gets returned here by DAX as a query language. All right, so look at the order of this query. So you can see that basically there appears to be no order in this query. And so it is possible to use some other query tools like exist in SQL. So you could say something like order by the sales quantity. Right, so I'm adding an order by clause. I'm saying go to the database, get me a single column table containing all the unique quantities and sort them by the order quantity. Sorry, by the sales quantity. And when you see that, you can see that the order has been changed here. But if I try to do something like order by sales customer ID, which is also a column in this table, then I get an error because I'm not allowed to set the sort order of a table if that column does not exist inside my query results. So just giving you a sort of a bit of a sense of the breadth of capability here and what you need to do and what you can't do. All right, just a couple of other quick examples. Evaluate products. If I run that query, it returns a table. You can see down here there's 504 rows in that table. So, I mean, doing this is obviously of limited value unless, using my point before, you wanted to do a poor man's paginated report and you just wanted to print a list of all your products, then this is how you might use evaluate products, and I'll show you how to do that to a greater extent shortly. But I could also write something more complex. I could say, what if I want a list of all the products that have a price greater than $3,000, for example? So you can see the price here, and there's not too many products here greater than 3,000. So as long as I'm writing a table function from the DAX language, so the filter function is a table function. Always look at the IntelliSense when you using Power BI or when you're using DAX Studio, because it will help you understand how the function works. This one returns a table. That's why we call it a table function. It takes a table as the first parameter. You can put a filter on it, and then the net result is another table. And so I'm going to filter the products table, and I'm only going to keep the products where the product price is greater than or equal to $3,000. If I run that as a query, you'll see that it returns 13 rows. I could increase the size of this if I wanted to. 13 rows, so there are 13 products in this database that have a price greater than or equal to $3,000. And the important thing, of course, is that this is a table function. If you tried to write this inside DAX as a measure, it would throw an error because a measure must return a single value, but it is perfectly legitimate to do it inside DAX Studio, because the DAX Studio is designed to accept this type of query. So just, if I could just summarize that, and then I might just pause and ask Michael whether there's any questions so far. I've got more to come, of course. So DAX Studio is it's the tool of choice to send a query to Power BI Desktop. You can also send queries through to Power Pivot for Excel, and also enterprise tabular models such as Power BI Premium or SQL Server Analysis Services Tabular. So it's the same tool, same language. Every query must start with evaluate, and the DAX function must return a table. And so here are some examples of DAX functions that return tables, but there's many others as well. So let me just pause there, Michael. Any questions from anyone?
Yes, so we have 2 questions already. So Christian has a question. Christian, do you want to ask him directly instead of me reading the question? Or maybe I should read because of time. Okay, so his question is, could you use remove filters instead of all in that example you gave where it was all sales, I think, quantity?
Could I use remove filter? That's a very good question. So I don't know the answer, Christian. So Christian's talking about when I said all, say, I'll just make something up, all products category, it doesn't really matter. So the remove filter function, if you're aware, is actually a syntax sugar determination of the all function. So there's another function called remove. I don't know whether it's going to work, but there's one way to find out. So we'll run that, and no, it doesn't. So I'm actually
probably
not
only in the filter.
Yeah, I'm actually not surprised, because it does. When I first learned DAX from Rob Colley taught me that the all function has two roles in life. One is to remove filters and the other is to produce tables. And I never really got my head around that, to be perfectly frank. But in this use case, I think that demonstrates that they're doing different things. So there you go.
Exactly. Thank you.
Okay.
Okay. And the second question is, so Odiano is asking, is there a DAX function that can return the running total from a table?
The short answer is no, but yes. There is no one function that can return a running total from a table, but you can certainly write a DAX query that will return a running total. And so it's a bit beyond the scope for this session, but just let me think, when did I write? If you have a look on my website and search for, I think it's Pareto analysis in Power BI. So if you go to my website, search for Pareto, the 80-20 rule, I'm pretty sure that the DAX query that I've written here could basically return a running total. So and I just, it's a good question. I understand why you're asking the question, but it's a little bit off topic for today. But if you go and have a look at that, I'm sure that will give you something to consider. So there's no straight function. It's important to note that DAX doesn't have any order in its data unless you explicitly create an order. So so that's one of the reasons that's a bit of a challenging problem.
Thanks.
Okay. All right. Great. So let's go back, and I'll move on to something a little bit more interesting. So this is just basically the intro, and so let's talk about summarizing data. Sorry, I should have put my phone on mute. So let's just talk about some of the different ways that you can use and summarize data. And so I'm going to use the same data I used before, but before we do this, I want to show you and explain to you this concept of the VertiPack engine. So the VertiPack engine is the engine that I called it before X velocity. These terms are used interchangeably. Technically, one's a marketing term, one was a project name. And so the VertiPack engine has actually got two distinct engines that together make up the database that is Power BI, called VertiPack. And so the first engine is called the storage engine, and the second one is called the formula engine. And these two engines do different things, but they're important and they work together. So the storage engine is a really fast engine. It's actually the tool that compresses the data when you load it into Power BI. This is the reason if you get 100 megabyte CSV file, you can end up loading it into 10 megabytes in Power BI. That's the storage engine that's compressing the data for you. Now, it's also possible that the storage engine can retrieve and do calculations on the data that's compressed without the need to decompress it under certain circumstances. And it's also multi-threaded and cached. So the storage engine is really, really important. It's actually the secret sauce that makes up the Power BI database. But there's this other engine called the formula engine. It's also important, I would say equally important. It is really smart. So the formula engine can do any calculation that you want. The storage engine has some limitations on what it can and can't do. And so it's unlimited calculation capability. The formula engine, to be a little bit technical, it tends to iterate in a row context, so it tends to go one row at a time, whereas the storage engine can work on blocks of compressed data all at once. That's one of the key differences. And also this engine is single-threaded and it's not cached. And so it's important to understand that there's two different engines. And if you're not aware of that, then I'm going to show you where you can almost see these engines. So it's the storage engine that makes your workbooks fast and small and highly performant. And it's the formula engine that combines with the storage engine to give you unlimited capability. The problem occurs sometimes when you write formulas that can't be handled by the storage engine and they have to be handled by the formula engine, and that can cause some problems. So let me show you the formula engine and the storage engine. So we're going to go back into DAX Studio, and notice up the top here I have this button called server timings. Now this is off by default, and I'm going to turn it on now. Now look, just have a look down the bottom here. I've got 3 tabs: output, results, and query history. And if I turn on server timings, I now get a 4th tab down the bottom here. So when I click over to this new tab, notice that I've got these 2 terms here, FE and SE. And of course they stand for the formula engine and the storage engine. And what this tab does is it allows you to run a query against the database and then get some insights as to how the Power BI database actually went about solving the request that you had. So this time I'm going to use something a little bit different, and I'm going to use a function called cross join. So cross join is one of those query functions that exists in DAX. It takes a table, one or more tables, and it returns a table. And so I'm going to cross join the employees table with the customers table. Now what a cross join does is it basically takes every combination of record. So if I quickly just jump back here, so the employees table has got 23 rows and the customers table has got nearly 20,000 rows. And so we're going to end up with orders of magnitude 400 and something thousand rows, because this cross join is going to create a brand new table that doesn't exist in the raw data, which is a list of all unique combinations of employees and customers. So let me go ahead and run that. So I'm running that query, and this is I'm deliberately doing this to illustrate a point to you. And it's still running. Wonder if I jump over here, let's see what's going on. So the query started somewhere. Okay, so now it's finished, and it returned 454,000 rows. And it took 15, this is milliseconds, see the duration, 15 seconds. So 15,000 milliseconds to generate that query. And you might want to do this because maybe you want to find out the sales for each of your employees by the customers that they've serviced. If I jump back to the service timing, there's a whole lot of information now that's become available. So first of all, you can see that the formula engines spent nearly 15 seconds of that job. Almost all of the elapsed time was actually done by the formula engine. It was always doing something. The second bit of information you can see is that the storage engine didn't do much work at all. It only took 6 milliseconds of effort. And also, in actual fact, if you look up here, if you look at the blue box here, notice it's saying the SE CPU. So the storage engine actually did 16 milliseconds of work, but notice this times 2.7 here. And so what that's telling me is the multitasking parallel processing that the storage engine can do. So even though there was 16 milliseconds of work, it did that multitasking across effectively 2.7 cores, meaning the elapsed time was only 6 milliseconds, even though the total time was 16 milliseconds. There's a couple of other things to note here. Note that we get how many rows there are actually. Now these are the queries that were executed. So there's 2 queries. The first query returned 19,000 rows, and the second query returned 23. So you would know from those numbers we looked at, they're the 2 queries to go and fetch the raw data from the database, and then it joined them together and spat out the output. And it looks to me like the formula engine did most of that work. And so that, I would say that's an expensive task. If I wanted to find out the total sales for the unique combination of employees and customers, this is a very inefficient way of doing it, because it actually returns 454,000 rows of data, and not all of those rows of data are actually in use. So that's not a very good function to use. So instead, I'm going to use a different function called summarise. So the summarise function, and I'm going to explain this to you. I'm going to just jump back here over to this small. Now, when you use the summarise function, the key thing to remember is that you always start with the data table, the one on the many side of the relationship, okay? So I'm going to write a query on the database. I want to grab my customer and I want to grab my employee, but I always start with the data table, the one that's on the many side of the relationship when using the summarise function. If you remember that, you'll be off to a good start. So I want to summarise the sales table. And now I'm going to go and grab the employee last name. Remember, this is in a different table, but because I'm starting with the sales table, I can reach up from the many side to the one side, grab that last name column and bring it back to the sales table. And then I'm going to do exactly the same thing with the customer ID. I'm going to go and grab the customer number. And I forgot my comma, so I'll add that in now. I need my brackets. Also, DAX Studio has got DAX formatter embedded. And so I just did a quick format, and now I'm going to run this query. Now, when you're trying to measure performance inside DAX Studio, it's really important that you clear the cache. So the storage engine does have the ability of fetching data from the cache. And so if you're trying to test performance and understand what's going on, you should always clear the cache before doing a new query. So here's my new query, and I'm going to run that now. And notice how quick that was compared with the previous time. So this particular query only took 17 milliseconds. The formula engine took 12. The storage engine took 5. There was only one query that got executed, and this query returned 1,850 rows, which just happens to be this same number of rows that is actually in the table. Now, I'm not showing you the table here. I could jump over here to the output and, sorry, to the results, and here are the results. So this is now a new table that doesn't exist in the underlying data, containing the names of our employees and the customer ID that they have serviced. And what's different about this query than the cross join is that the summarise function will only fetch records that exist inside the underlying data. If D Castillo did not have any transactions with customer 18000, then that combination will not be returned by this query. And that's one of the reasons why this is much more efficient. So very fast and very performant. And so that's a much better way of fetching data. Okay, but what if I now want to know what's the total sales for each of these combinations? So when the employee Del Castillo serviced this customer 19520, how many sales did they have for that unique set of transactions? Now, it is possible that I could come in and I could add some more parameters in here. Now, just to save some time, I'm going to skip this, but instead, the best practice is to use another DAX as a query language function called add columns. And so add columns, if you look at this, add columns takes I lost the IntelliSense. Add columns takes a table as its first parameter, and then you can add new columns. That's what add columns does. And so if you think about it, this is a table, right? I just generated the table. Here it is here. I've generated a table, and now I can use that table as an input to add columns. And so what I'm going to do is I'm going to take this table, the one that I produced already, and I'm going to add some new columns to it. And the way this works is that you give the column a name, so I'll just call it sales. It can be any name you want. And now I can use one of my measures. And so I'm going to bring, say, total sales quantity in, close the brackets. I'll do the formatting. My formatting's pretty good anyway. Clear the cache. And when I run that query, you'll see that I've now got a summary table containing all the unique combinations of my employee and customer, and I've also got the total sales that exist within that that group. And if I jump to the servings timings, you can see that this is still very fast. 2 queries return the same number of results, and it took 28 milliseconds. So this is really the power of Power BI, the VertiPack engine, working at its best. And so in this case, I've showed you how to produce a summary table. Now, incidentally, what you could do with this summary table is I'm going to copy this. In fact, I'll copy the whole lot. I'm going to copy that query, come back to Power BI desktop, and if you come up to the modeling tab, there's this new table function. So when you go new measure, new column, you're generating a scalar value. But when you click new table, you're effectively using DAX as a query language. And so I can't put a measure in here, but I can paste my query. But it's important to note that you do not use the evaluate function inside a new table. And so you remove the evaluate function. This is the only time that you write a DAX query and don't use the evaluate function, is when you're using the new table button. So if I run this now inside Power BI desktop, this will now generate a new table called test table. And if I come and have a look at it, it's exactly the same. It's exactly the same as the query I just ran. There's the name of the employee, the customer ID, and there's the sales. And note, it's got exactly the same number of rows. So if you are wanting to build one of these summary tables as part of your model, I actually like writing those queries inside DAX Studio and then cut and paste them back before I, as just an improved way, an easier way of doing that. Okay, I'm just conscious of time, so I'm going to jump back to Michael. Any other questions, Michael?
Yes. So Odiano is asking, how do you ensure there are no duplicates when you use a cross join? Duplicates are a result of typos, for example.
Well, by definition, cross join will it's just a straight combination of the unique, sorry, not the unique setting, it's the rows. So if you had a table, for example, perhaps I could have opened up Excel before I did this, but if your table contains 3 values, A, and your second table contains 1, 2, 3. So if your first table is this and your second table is this, it's still going to do a cross join. So you're going to end up with duplicates because you're going to end up with A1, A2, A3, then A1, A2, A3 again, and then A1, A2, and 3 again. So, so I'm not sure if that answered the question. It's going to return the unique combination. So.
Yes, I think you did. And
sorry, if I may.
Yes.
Okay, and so if you have like a data table and you have like 10,000 rows in that data table, and you do a cross join on that data table, and all you want to do is just have, say, columns from another table, say 2 columns, get joined to that data table. I'm expecting 10,000 tables. So does cross join allow for that?
Well, first of all, I don't recommend using cross join. So I used it as a demonstration to show how inefficient a formula can be. So there's very few use cases that I can think of, if any, where I would use cross join. I think this actually raises a very important point, and that is just because you can use DAX as a query language doesn't necessarily mean that that should be your default go-to solution. So, and this is particularly true if I could give some advice to people that come from a SQL background. Most people that come from a SQL background are used to querying the data. And so if I could explain it this way, a SQL developer is used to the concept that they have to understand the logic of the database. They write the script, they send the script to the database, and the database sends the summary table back, and then they use that summary table for whatever purpose. Now, under normal circumstances, you don't need to do that in inside Power BI. And so I'll give you a good example here. So this is, and I'll jump into the third example as well, because I'm just conscious of time. We've sort of got about 10 minutes to go. But this is, I'm going to talk about performance, but I'm also going to continue on this point that I'm making. So this is a list of customer last name. So this is the name of the customers. And I'm going to, I want to show you these measures first. So this one here is just sales quantity. So just sum the quantity in the sales table. So if I put that into this table, put a tick there, it's a very quick measure. You'll see that it renders almost instantly. Now I just want to finish this point about the DAX query and the cross join. See, if you're used to being a SQL programmer, you would try and write this. You'd go, you know, select customer last name from customer, and then you go select sum the sales quantity as total sales quantity, group by last name or something like that. So you're used to doing that. The whole point is that Power BI does that automatically for you. That's what the visuals do. The visuals are actually building the query for you. It's one of the hardest things for SQL programmers to get used to when they start using Power BI, is that they no longer have to think about how to build the table, because Power BI does it for you. And just to that point, if I jump up here to View, Performance Analyzer, I've got this query here, I've got this table selected, and if I start recording and refresh this visual and expand here, you'll see that this is how much time was spent. So there was a DAX query that was generated. It took 11 milliseconds. It took 97 milliseconds to render on the screen. And there were some other things that took a quarter of a second. But if I click copy query here and come back here and paste this in, this is actually the, I'm going to have to make it smaller. This is the query that was automatically generated by that table visual without you even knowing. And it's using the optimal DAX query language to do that for you. The visuals in Power BI write the queries for you under normal circumstances. And I'm sort of introducing this concept to you. And I could actually run that query now and return exactly the same table as that visual did. All right, so just in the interest of time, I just want to finish off this performance point that I want to talk to you here. So I'm going to remove the total sales. I want to show you, I've got this other measure, total sales value, that it's a SumX through the sales table. It takes the unit price and multiplies it by the sales quantity. And when I put this measure in, let's have a look at what happens. So I'm waiting, 1 red apple, 2 red apple, 3, 4, waiting, 5. Why is this measure taking so long? All right, so see how long that took? Why is that measure taking so long? So this is another use for DAX as a query language. Remembering we've got that storage engine, formula engine insight as to what's going on. And so I'm going to show you how to test this measure in DAX Studio. So I'm going to come over here. Let's get rid of this. And I have to use evaluate, as you know. Now, if I try and bring my measure, total sales value, in here and run it, it throws an error. Why? Because if you're writing a DAX query, you must return a table, and a measure always returns a value, not a table. But there's a little trick, and that is the curly brace, the little, I don't know where they are on your keyboard, they're above my square brackets. I call these the curly brace. If you wrap a measure or any other value inside a curly brackets, it turns that value into a table. Okay, so now when I run this query, you can see that the query started, it's finished, it took 3.2 seconds. If I come over to the server timing, you'll see the formula engine's done nearly 3 seconds of work. Now compare that with the other formulas that we wrote that were 26 milliseconds. I mean, this is 100 times slower, right? So there's something's not right with this particular formula. Also, notice the information that we get here. The first query returned 6.7 million rows. We've actually gone and fetched every single record from the sales table in order to complete this formula. So that's a problem. When I click on these queries, you can actually see the query over here. Now, this is not SQL. I would call this pseudo SQL or SQL-like code. It's basically a human readable representation of what the engine is doing under the hood. Technically it's not SQL. And if I look at this one here in bold, this one's a problem, because anytime there's a query in bold, typically you've got this callback data ID over here. And this is a big topic in its own right, but anytime you see callback data ID in a query, what that means is that there's a lot of to and fro between the formula engine and the SQL engine. They're basically doing a handoff. They're doing, you go and get the data, I'll have a look at it. You go and get the next row, I'll have a look at it. So basically that's a bad way of writing this formula. All right, so I'm going to write some alternative formulas. And so I'm going to come down here to this sales value measure, and I'm going to right click and select define measure. And what that does is it actually puts a new line of code inside my query. And what this line of code does is it will override the formula inside Power BI Desktop. Instead of using the version of the formula in Power BI Desktop, it will use this formula that I have inside my query. So this gives me an opportunity to change that query, to tweak it and see what happens. Okay, and so now depending on how much you know about DAX, you may already know what the problem is here. There's a couple of problems actually, but the first problem is I'm stepping through the sales table, and the sales table has got 6.7 million rows. So it's a much more efficient formula to step through the products table, because the products table has got, I don't remember, a lot less rows than that. So let's run this. Now I'm going to clear the cache. Remember this number, total 3.2 seconds. Clear the cache. Remember 6.7 million rows, and then I'm going to run the query again. This time it took 9 milliseconds. The first query returned 500 rows instead of 6.7 million. We've still got this callback data ID, so that says to me something can be done more efficiently as well. Once again, to save time, this unit price is a measure, and because I'm stepping through the products table, it's much more efficient not to use a measure, but instead to use the price column. I'm stepping through the products table. Because I'm in the products table, I can refer to the column without being a measure. And so I can do that. And in fact, just to save time, I'm going to wrap this inside all. Actually, that's not the right place to put it. I really need to put it over here. I could step through all product price. So this is actually the most efficient way of writing this formula. It'll just save a little bit of time. We're pretty much out of time. So I'm going to clear the cache. I'm going to run that query. This time it took 35 milliseconds. It only returned one query, 254 rows, no callback data ID. I've debugged my formula. I can now copy this, Control C, go back here to my measure and replace the old measure with the new, more efficient version. And if I remove that and now add it back in, remember before it took about 3 seconds before it appeared. When I click on it now, it's instantaneous. Now look, there's a lot going on there because I've introduced some techniques, but the whole idea was to show you that you can use DAX as a query language for doing these other things. So if you are going to use DAX as a query language for testing your measures, you must convert the measure into a table. I did that using the curly braces. You can use the define function to rewrite your measure or even create new measures inside DAX Studio. and you can clear the cache, and you should clear the cache to make your tests more realistic. And then you should never iterate over a table when you can iterate over a column. That's a general rule of DAX language, although there's always exceptions. So Michael, we're pretty much at the top of the hour, so let me pause there. I didn't get to do my my last example, but any other questions?
Okay, for now, no new questions from the audience. No new questions.
Okay, do we have? Can I squeeze in a couple more minutes then? I want to.
Yes.
All right.
Yes.
So let me show you. I want to show you one more thing, which is what I call my my poor man's paginated reports, because I think you'll be very interested in this. So if I jump into Power BI, so I've got a Power BI Pro license. You must have a Pro license to do what I'm about to show you. In my workspace, I have got that same database that I've been using, this one here, that's got 6.7 million rows in it. So if I come to this database, I can click on the menu and I can select Analyze in Excel. Now, many of you would be aware of this. So what I've done now is I've created a brand new Excel file on my computer. This will open up. There's a couple of warning messages. I need to enable editing and enable content. And over here, you'll see that once the connections have been established, I've got exactly the same model that I had before. And so I could do the same thing as I did before. I could bring my customer last name, and I could bring my total sales quantity, and I can build a pivot table. And there is no data stored in this Excel file. The pivot table creates a query. It's a DAX query. It gets sent through to powerbi.com. Powerbi.com runs the query, gets the answer, and returns it back to Excel. So we call this a thin workbook. Now, look what happens when I do this. If I take this pivot table and double click, what it does, just like a regular pivot table does, is it goes and gives you a list of all the values that were used to generate that particular result. So this now is not a pivot table, it's technically a table. And in this case, it's a table containing the first 1,000 rows that together made up this answer of $3.3 billion. Now here's the trick. If I right click this table and go Table, Edit Query, I can now make a change to this command text, and I can write DAX as a query language, exactly as we've been doing. Now, I don't know whether I have anything here, but I'll just quickly, I think I'll write it back here because it'll be faster. So if I go evaluate, I'll go summarize the sales table. Remember, always start from the data table. I want the customer's last name, and then I'm going to add columns to that table, put a comma, and I want the total sales, and I'm going to use the sales quantity. So now I've got this nice DAX query. If I run it here and look at the results, here is my table. And if I copy this, and this time I do need the evaluate, I think, we'll soon find out, I can paste this query here in the command text and click OK. And when I do that, this table is now the generated results of that DAX query. I can go back and delete this pivot table. I don't need it anymore. And from now on, I can edit this query anytime I want with any valid DAX query syntax, and it will go and fetch that table and bring it back and display it in Excel. And because it's in Excel, you can set up page layout, formatting, those sorts of things. And this is what I call poor man's, paginated reports. So I can set the print area. I can go and change the way it works, to fit one page, as many pages tall as it wants. I can have repeating headers and footers, pretty much whatever you want. So that's a neat trick to create an Excel file that connects to your Power BI desktop file and you can write DAX as a query language to return a list of values in Excel, which is then much easier to print or generate a PDF or so on. Okay, so I'm about 5 minutes over time, so sorry about that. At different times I take longer to talk and explain things, but so yes, Michael, thank you. Back to you.
Oh, wow. It's a lot of many wonderful things you've shared that I've been taking notes. I can't remember any guest session I've had where I had to bring out my own notes and start writing, but yours, I've been finding things that I'm like, oh boy, and I think I remember it, but it's better to just take them down. I want to ask, is it possible we can get the slides?
Absolutely.
We ask also to, especially those who enjoy. Personally,
absolutely.
Okay, thanks for that. So I have some questions. In addition to the 2 I told you, I hope it's okay if the questions take you, say, about 7 minutes more. Do you have that time for us? I know it's really late for you.
No, it's fine. No problem.
Thank you. So question number 1 is, by the way, those of you in the audience too, it's almost like we're having a personal session with him, because we are not that many that all our questions is able to answer. And I'm hoping that those who watch the recorded session, they will be happy that we'll ask the kind of questions they want to ask. So my question number 1 is, you've used summarise in a way that I never thought of. I've used cross join, and I know it's been slow, but I never knew that I could switch. I could take it off by using a summarise. And so I want to ask you, what formulas do you normally use in your consulting work? When you're working on live projects, what are those not so used formulas, or formulas people don't think of as being able to use them in some creative ways that you end up using and you use them a lot?
Yeah, I think it's the 80-20 rule here. So you'll get 80% of your requirements covered with 20% of the DAX language. So, calculate, I use calculate all the time. Sum, I tend to use sum rather than sumx. That's a whole topic on its own, so I won't go into that. But sum is just easier. It's the first language that it's the first function that I'd learnt. Definitely the filter function. So pretty much you can do anything with the filter function. And then I use a lot of the inbuilt time intelligence functions, because that's obviously, it is a big part of the way most businesses need to solve their problems. So that makes up most of the requirements. I very rarely use things like summarise or calculate table. Different people have different approaches. If you look at the Italians and some of the things that they do, and my view is because they come from a SQL background, they tend to think of the problem and they tend to structure these tables using summarise and the like. And so I'm not saying it's wrong. I'm just saying the great thing about this language is that depending on where you came from, there's a solution that you can use. And so yeah, you just need lots of practice on trying to solve problems. If I could give one tip to people, if I gave anyone just one tip, it's when you try to write a formula, always create a visual to have a look at what's going on. It's the best, most important thing you can do. So if you're trying to write, if I'm trying to write a measure here showing me, sales year to date, there's no way I would start that problem without setting up a visual that has the date going down the page and the sales for each of those dates. Now I can't show that because I don't have a calendar table loaded in here, but if I was trying to write a formula that gave me the top 10 customers ranked, there's no way I would write that formula without setting up this visual. Customer and their sales, and I'd sort it descending. I can immediately see the problem that I'm trying to deal with. And so it's just one of the most important things to do inside Power BI writing measures is to create a visual so you can see what's going on. And then normally it's the standard functions that I talked about.
Thank you for that. A second question is, So when you work on a project that it's taking more than the time you expect or the usual time you spend on similar size of projects, where do you notice that the extra work, the extra trouble you're facing typically come from? Is it from the data transformation side, or is it within the DAX and the modeling side, or it's more of the visuals? Or so what aspect typically gives you that extra work?
Yeah, and it's many of those things that you mentioned. So in my experience, if you get the data model correct, everything else is easy. So when I say the data model, I mean this. If you have a good dimensional model, so this is a star schema, right? So this is a star schema. Power BI was built and is optimized to work with a star schema. If you don't have a star schema, it's not wrong, but it can be harder. And so where if I get called in to help customers with work that they've already done, I'm getting better over time. But nowadays I just push back and say, no, stop. We're not going to. I'm not going to help you with this model. If you need help with this model, I'm not the person to help you. If you want to help get this working properly, then I'm the right person. But we're going to start with the model. Must get the model right. If you get the model right, fit for purpose, the DAX is relatively easy. Now, in a simple case like this, where we've got a simple 3 or a 4 table star schema, if I was to add the calendar table, I mean, the world, unfortunately, is not always that simple. So the models will tend to be more complex than this. So that's one place that will definitely burn time. The other place is definitely trying to transform your data on load. So if your database or if your core system has customers are slowly changing dimension, where the customer information is changing all the time and the table contains multiple different records for the customer, then you definitely need to prepare that table so that it is basically a table with a primary key. A primary key, one customer is one row. And so there can be a lot of work in there. And even though Power BI will work on Excel as a source or CSV as a source, it can very quickly become very complex if you're asking Power Query to do a lot of ETL transformation, particularly when you get large data sets and many files. And so, you know, what I've learned over the years is that even though you don't need a data warehouse to do projects, it can very quickly become a good thing to do, because if you can move some of that transformation work into a more traditional relational database, it can take a lot of pain away. It's particularly true if you don't have SQL backend. So if you've got like CSV files, Excel files, some of the less friendly SQL products such as MySQL or PostgreSQL or anything on AWS, you know, that can definitely be a problem as well.
So, another question I have is, so you've mentioned 3 things now about, I think maybe more, but I remember 3 things about performance, and I just wanted to maybe say the other quick ones that you normally watch out for in your work to improve performance. So one of what you've mentioned is the fact that, you know, always iterate over a column if you can, and almost all times you can, you know, over versus doing iteration over a table. Then also you mentioned okay, not to, since you're here, you're going to answer. I just want to ask you, you know, when you want to improve maybe something you've done or something someone else has worked on performance-wise, what are like the quick things you kind of just quickly check out for and do?
Sorry, I'm not quite sure. So what was the actual question, Michael? Sorry, I didn't quite get the point.
So the question is that, what are your quick performance tips? You know, the things you watch out for. You mentioned some.
Yeah. Well, I mean, I've given you a couple already, but other couple of things. The things you need to be most aware of inside Power BI. This is a bad example. If I jump to the sales table, one of the most important things in Power BI is how many unique values exist inside a column. right? So this quantity column inside my sales table of 6.7 million rows has 1,000 distinct values. So generally speaking, that's pretty good. But if we take an example, let's say I don't have a date in this particular database, but a common thing I see is people store transactional information with a date time column, right? A date, combination of date and time. What's worse is the time is in hours, minutes, and seconds, all right? Now, if you think about it, if that's some sort of transactional system, there's going to be a high number of unique values in that column. And that will definitely have a negative impact on performance. On very small workbooks, you might not see it so much, but wherever possible, focus on making your columns where you have a choice, reduce the amount of uniqueness within your data. So if you just simply split the date column, date time, into two columns, one for date, one for time, you will get orders of magnitude improvement as a general rule. If you can truncate the seconds and only load the minutes, you're better again. If you can round the minutes to the nearest 10 minutes, or better still, round it to the nearest hour, just load the date and the hour of the day as an integer, you're way better off. It's probably the most important tip inside Power BI is the number of unique values in a column matters. Now, if you've got a small table, my customers table's only got 19,000 rows, my employee table has got 23 rows, it doesn't matter. But if you've got a table of 6 billion, 6 trillion, even 60 million rows, then these things will definitely make a difference.
Thanks a lot. Okay, so 2 questions came in from Odiano saying that, do you have any advice on troubleshooting steps when you break a report?
On what steps, sorry?
Troubleshooting,
troubleshooting. Very good questions. To me, I describe it this way. You're camping down by the river, right? And you start to see some pollution drifting past. And you say to yourself, what's causing that pollution? What's causing that problem? Well, what you have to do is you have to head upstream and go looking for the source of the problem. And I always use that paradigm when I'm trying to debug a problem. I assume nothing and I start heading upstream, checking every single thing along the way. And so I will always build a visual like this, exactly as when I write a measure. I always start, if I've got a problem, then I will put something in a visual like this. So, I mean, I can simulate this, right? So let's pretend, so this is not a real use case, but if I did something like, I don't know if you've ever written a formula where you get the same number all the way down the page. And so forget about the fact that I hard coded that problem, right? But if you've ever come to a point where you're getting the same number, you don't understand why it's working. This is a very common problem. This is what I do. First of all, take a copy of that table, put just that on one visual so that I'm not distracted by slices and cross filters and charts and stuff. And then I start to work my way through. Always start with the tables and the relationships. So the first thing I want to know is, where do these columns come from? So last name, so I click on the table and you'll see that these are highlighted. So I can see something's coming from customers, something's coming from sales. Last name, I hover, customer's last name. This is a measure. I'll go and check the measure now. And so let's pretend that it's not bogus measure. Then I'll go and check the relationships. I always do this next. Come over here. Okay, a relationship between the customer and the sales table. I always check to make sure it's correct. So many errors are caused because the relationships aren't correct, or maybe there's no relationship. I mean, a good example. So let's, this is a different, I'll change this out. I'll bring this other measure in, total sales value, and I'll bring this in. So here's another example. So there it is again. same problem. What's wrong? So same process. Last name is coming from test table. Total sales value is coming from here. If I come over here and check, there's no relationship between the test table and the sales table. There's your problem. Yeah, so that's the general process. Set up a visual, check make sure that you've got the columns that you expect, go and check the tables, check the relationships, make sure that they're correct. I mean, then you really just have to look for clues. So if the next clue would be, if I assume that there was a relationship, you have to start asking yourself, why is this column not filtering this value? It's not the relationship. What else could it be? And then you have to start, looking at the alternatives. But that's the basic process that I go through. And when people come to me with problems, I don't know the answer. I just know the process, and that's the process.
Christian has a question for you, and the question is there a specific reason for not updating the model view to the latest February update?
Is there a specific reason for not updating the model view to the latest February update? Christian, you're a troublemaker. So yeah, I mean, if I update this, there's actually a problem with the latest model view. I know Christian knows this, but if I upgrade this to the latest model view, one of the problems is that in this latest release, they've put this one-to-many, the one and the star is now part of this arrow. And look, plenty of well-meaning people at Microsoft, I'm sure the person who did this believed that they were doing the right thing, but I think there's a pretty broad view in the community that this is not the best way to deploy this. And one reason is quite simple, and that is that if I come over here and I'm looking at this, I can no longer look down here and see 3 stars. If I see 3 stars there, I know that that's a fact table. And if I come up along the top here, and if I look along these tables here and I see, 1, 1, 1, 1, I know they're dimension tables. And when you get complex models, and I've seen a few complex models come through, this just doesn't serve the purpose as well. But that's not the reason I didn't do it, but I suspect that that's what Christian was asking. So there you go, Christian.
Okay, so thank you very much. You've come to the end of the usual questions, just the last 2 ones, which is you telling us about your journey, how these all, have you always known BI? I wanted to say, have you always known Power BI, but then Power BI is not that cool. So I'm sure we want to hear your interesting journey from.
Well, I mean, seriously, you don't have time to hear my journey. But I tell you what, I'll give you the quick answer. The quick answer is I've always been a data guy in the wrong job.
Cool.
But to be fair, there was never a product like Power BI around. I wonder if Power BI had been around 30 years ago when I was early in my journey. I had a chance to do a data analyst job at one stage. I definitely could have done it, but the reason I didn't do it was not because I didn't love it. It's because I didn't know the future of that role. I think now with citizen developers, with this product Power BI, if you want to be a career expert as a data analyst, I think you can do that. So look, it's a very long story, but I'll SS BI podcast. If you're interested in hearing my story, if you find this SSBI podcast by Lars Schreiber, a friend of mine, he did a podcast with me. Here it is here. So SSBI podcast. It's available on Apple and Spotify and all those sorts of things. So that's an hour and 20 minutes me talking about my journey. There's also a few links to blog articles about my journey. I don't want to repeat the stuff that's out there in the public environment. And then secondly, if you search for P3, I think it's called Raw Data Podcast. This is Rob Colley. Rob got me, here it is here. Rob Colley introduced me to Power Pivot back in the day. And this podcast talks about that journey as well. So I don't want to sort of spend a lot of time rehashing that stuff. So there's 2 great places to learn if you're interested in my journey. But everyone's got their own unique journey, and I mean it seriously when I say if this product Power BI had been around 30 years ago, I'm sure my life would have been different, because I think I would have gone down this path.
Wow. I've pasted the link from the SSBI blog, the podcast about you talking about your journey. So
yeah, great. And I'll send. I can't send messages, so the other one's raw data by P3. Yep.
Raw data. I'll do that later. Maybe I'll just notice raw data with P3. P3. Okay. So, what's your advice for? That's the last question. What's your advice for someone starting out now?
My advice is get practice. So I presume when you say starting out now that you like data, maybe love data, you like Power BI, maybe you love Power BI, and maybe you're doing another job and you want a career using this product. So what do you do? So most important is to get some practice, and there's various ways of doing that. One of my favorites is to go onto the forums, community of powerbi.com, and help someone with their problem. It's very difficult to build a meaningful Power BI report if you don't have any meaningful data. So find some meaningful data. If you can find it at work, that's great. Otherwise, personal data. Otherwise, jump on the forums and help somebody else. You'll be amazed at how much you learn by helping other people. Michael, you and I had a bit of a chat just before we started, and you said to me, we talked about the fact that I do a lot of sharing online and blogs and stuff. And the things that have really helped me with depth of knowledge are writing it down so that I can explain it to somebody else and helping someone else with a problem. If you learn this product with the view of teaching somebody else how to use it, you'll learn at a level of understanding that you will never reach if you're only doing it for your own personal use. So get some, and then build something meaningful, hopefully for work. And even if you're not allowed to, if you can download Power BI Desktop, all the better. And just start using it in your day-to-day job. I found it very difficult to convince non-Power BI people, particularly early on, that they needed this tool. But what I could do is I could build fantastic Power BI reports and just say, oh, here's the answer here. You go to a meeting, they say, can you tell me what happened? I say, hang on, here it is. Here's the answer. And they go, how do you do that? Sooner or later, someone's going to ask you, how did you do that? And when they do, you'll be ready because you'll know how to do it. So just start the journey. Just believe in yourself. Start the journey. Get on the train. Head down that track. Practice. Build something meaningful. Sooner or later, you make your own luck. I believe you make your own luck, right? Sooner or later, you'll be the luckiest person in the world. So that's my view.
Thanks a lot. In fact, we had more people towards the end than at the start, and sure.
Well, hopefully people can go back and watch it from the beginning, and I hope there's something in there for everyone.
Yeah, definitely, I'm going to download it right now and broadcast by 6 p.m. The same joining link, so people who are in here who didn't join in early at the start, you'll be able to watch it from start, and it's also good for me because at the beginning I was being distracted with trying to get people to remember to join. So I want to say a very big thank you, Matt, for this. In fact, your personality is one that now makes me even a lot more, like my respect for you has gone a lot more higher and all, because it's you have this humble way of sharing what you know, and I now seen someone I'm going to take as the goal. So the future becomes more like, I'm going to try and follow your steps and see how I can come to this level of expertise and ability to really try something new. When you answered Christian's question, you didn't say no. You said not try it. You're going to try it, and I took some of that also. So thank you very, very much. And
thanks for the opportunity, Michael, and great to be able to. Well, I didn't get to meet too many people, but hopefully, we've had this chance to interact, and hopefully there's some value there for you. And good luck to everyone on your own journey.
And one last thing is, I know you have courses you run, and so I know people will want to know how can they even. I'm going to quickly share the screen and go to your. You can direct me if there's a particular one I need to show them, or I just want to show them that they can. I'm going to copy the link also too and paste in the chat box. You run courses, there are even online ones they can take without them having to travel down to Australia to meet you. So are there any ones that maybe has a particular start time that they can maybe join in, or they are always running all of the times in the year? Like they can just subscribe anytime, or are there some that have a definite start time and end for the classes?
Sorry, the start times for what? Sorry, for classes, you're saying?
Yes, so for your trainings, I want to show them.
So unfortunately, in your time zone, my classes aren't fantastic for the live classes, but I do have video on demand classes as well, which is available through SkillWave. The information is there. And so I don't know if I can't remember what I put on that slide. So there's a couple of courses. Christian's been on my Supercharged Power BI course. If I could just quickly share this again.
Okay, yes, share yours then. So start sharing mine.
I just got to find the right button. Yeah, so this one here, I've got a short code, and this QR code also works. So this is one of the live classes that can work. It's still, your time zone is not perfect, but I do a morning and an afternoon session. And basically, the way this training course works is that you read my book, and I've just updated my book. I didn't show you my intro slide at the front, but this is my brand new book. This one here. So I've just updated my book, and so basically the way this course works. Whoops! I thought I copied it. Obviously I didn't. So see this black one here. Mm-hmm. This is the third edition of my book, and so the way this course works, this one here, is that you read the book, but you have me holding your hand. So it's like a 7-week semester. You read a few chapters, you do the exercises, and every week we have a live Q&A. So it's basically like this. You can ask me any questions, and I also have video, streaming video, which supports the book. So it's, some people prefer a bit more structure rather than just reading from a book. So that's probably the easiest one for most people to take up if they're looking for a little bit of extra help. I do have another website joint venture, you may be aware, skillwave.training. This is a JV that I have with Ken Pauls and Miguel Escobar. They're two of the greatest Power Query guys that I know. And we've got a whole stack of courses that are available in here, and most of these are video on demand, so you can take them at your own pace and your own speed. You can see a couple of these are my courses, and some of them are Ken's courses, and so on. So another great place to learn.
Yes, thank you very much. I'm going to put the links in the chat box. Copying the link for the SkillWave one, and I'm going to put it in the chat box now. So thank you very much. We've taken a lot of your time.
No problem, Michael. Thanks again.
It's been a wonderful session. I'm really glad that we were able to get you. More importantly, you are willing to accept our invitation, even though we are a small community. I'm sure you are used to speaking to a larger audience who will have gotten much more than this, actually. But it's good. I'm going to tell them how much they've missed, so they watch the session they missed. Sure. So thank you very, very much.
Thanks, Michael. Okay. Thanks, everyone. Have a good day.
To all the audience, thank you. Bye. See you next week.
Bye-bye.